So let's study the effect of temperature on resistivity. So as you know children, the rho is equal to m upon ne square tau, where m is mass of electron, E is charge on electron, n is number density of electron, and tau is the relaxation time. So let's consider first in the case of the conductors, metallic conductors, how the resistivity varies with the temperature. So in the case of a conductor students, as you see that my m, n and e, that is the mass and electron, mass and charge on electron is constant. N is constant because we are taking the say one material at a time. So my n is constant. Say for example, if you are considering copper, so n is constant. Now as you see that m, n and e are constant, so my rho is inversely proportional to T. So as you increase the temperature, what will happen? The collisions will increase, the collision will become more frequent, and as the collision will become more frequent, that means my tau will decrease, relaxation time, and as the relaxation time will decrease, what will happen? Rho will increase because rho is inversely proportional to temperature. So as the rho resistivity will increase, my conductivity will decrease. What is conductivity? Conductivity is reciprocal of the resistivity. Okay. So conductivity is noted by sigma. So it is reciprocal of the resistivity. Right. So what we have concluded? So that means on increasing the temperature in the case of my conductor. So on increasing the temperature, what will happen? My resistivity and resistance both will increase. Alright. So this is about the metallic conductors. The next come to the semiconductors. Now in the case of the semiconductors, now my m, that is the mass and charge, are constant. Now tau is also constant because there is no collision. Now what happened in the case of the semiconductor? On increasing the temperature, what will happen? The electrons, they will jump from valence band to conduction band. So as they move from valence band to conduction band, that means they become free to conduct. So that means on increasing the temperature, what happened? My n, that is the number density of electrons, it increases. And as the number density of electron increases, so as we see that rho is inversely proportional to n. So as n increases, my rho decreases. That is the resistivity and the resistance, they both will decrease, but my conductivity will increase. So in the case of your semiconductors, the conductivity will increase with temperature. So rho, resistivity and resistance will decrease with temperature. The next comes to ionic conductors. So in the ionic conductors, what are my charge carriers? My positive charge ions and the negative charge ions are my charge carriers. So what happens in the case of my ionic conductor? On increasing the temperature, what happens? The force of attraction decreases. And as the force of attraction decreases, that means the ions will move freely. And as ions will move freely, what does it mean? Ions are moving, that means my conductivity will increase. If conductivity will increase, my resistivity will decrease. As I already told you, resistivity or conductivity is reciprocal of each other. So again, what we have seen in the ionic conductor also, the conductivity will increase with temperature. So in both conductor and semiconductor, the conductivity increases with temperature, or I can say resistance or resistivity will decrease with temperature. Then let's come to electrolytes. In the case of your electrolyte, what is there? The interatomic attraction is there. The interatomic attraction is there between solute-solute, solute-solvent and solvent-solvent. So what happens as we increase the temperature? What happens? The viscous force decreases and the ionic attraction also decreases. So as they decreases, what happens? The ions will move freely. So as ions will move freely, again what will happen? Our conductivity will increase or resistivity will decrease. So this is all about the variation of resistivity with temperature. This is also very, very important from the examination point of view. That is from your CBSE paper, board papers. This topic is very, very important.